a frequency distribution of a very large number of proportion differences. What is the center, the mean, of this frequency distribution? The right answer? Yes.
Yes.
All right, the mean, most common outcome, the mode, the mean, or the mode, the median, the mean is the right answer. What is the right answer?
Not the wrong answer.
Wrong answer.
Between the two,
What is this? Someone read this to me.
the right answer is one and two.
So this P with a bar over it, that's sample proportion 1.
And two.
That's sample proportion 2. What's the pi symbol here?
Population of one and two.
True population proportion. True population proportion 1 minus true population proportion 2, so that's the difference. The true difference in reality between technology resistors in Florida, technology resistors in California. If we were to ask them all and they were to tell us the truth, we had the right data, what would it be in reality? It would be that, the proportion difference. Okay. And then, so this is a normally distributed bell curve. The center of the bell curve is the right answer. Sometimes we're going to be off by being a little bit high, sometimes we're going to be off by being a little bit low. But there's an equal probability of both those things happening, as is equal probabilities of more extreme things happening. Because it falls into a normally distributed pattern, we can predict how many of our sample proportion differences will be within a certain number of standard deviations. Speaking of standard deviations, what do you think this is? Somebody just read the first part of that to me and I'll explain the
The meaning of the proportion one to minus proportion two. The standard deviation of the standard deviation of the distribution proportion one minus the standard deviation of the proportion two.
Yeah. I feel like that's pretty much right on it. Yeah, absolutely. More succinctly, I would say this is the standard deviation of the sampling distribution of the
The proportion difference, the
sampling
difference, sorry.
distribution of the sample proportion difference.
I forgot the difference, okay.
I think you had I think what you said was correct. I really did. Okay, so this, we just need the various components that we would expect. Instead of doing proportion 1 times 1 minus proportion for one population, we do it for two populations. We add those together, it's going to be bigger because we're dealing with more diverse, we're dealing with two different populations. N is the sample size. So the bigger the sample size, the smaller this number is going to be. Since these numbers are in the denominator, they make this final result smaller as they get bigger and bigger. Okay, so that's sampling distribution and the sample proportion difference. It is a probability distribution of all possible values of the sample proportion difference, with a certain sample size from population 1 and a certain sample size from population 2. These bullet points are just some fine print reminding you that population 1 minus population 2 for the sample is the sample difference, and we compare that to the true population difference. This frequency distribution is normally distributed based on the central limit theorem, provided that we have sample sizes that are big enough. What is big enough? Well, remember that a sample size for one proportion needed to satisfy both of these two little equations. So if we're taking a proportion difference, we just want both of the sample sizes to satisfy these two little equations. The center of this frequency distribution is the true population proportion difference. The standard error is this. It's on your slides, it's the same thing that was on the graph. We talked briefly about it, now you'll just use the formula. Building a confidence interval. So we're going to have some sort of point estimate, plus or minus some amount. Our point estimate is our sample proportion difference. So we're going to sample a bunch of technology people or people in Florida, find out how many of them are resistant, sample a bunch of people in California, what's the difference between those two? That is our point estimate. Sample proportion 1 minus sample proportion 2, plus or minus some amount. Some number of standard errors. Depends on how confident we want to be. We want to be 95.5% confident. This is going to be 2. And then we know how to solve for the standard error. We just plug those numbers in. With actually one slight modification. Remember, as Kay pointed out, we do not know the true population proportion 1 and 2 before we start the problem, because that's what we're trying to figure out. So we substitute in the sample proportions. Alright, great. Let's try a couple of problems. Let's try page 296, number 40.
There we go.
I think he's gonna have that. It's gonna watch that,
Because I want to go back to my notes here. And I need to fix.
Yeah.
I don't have my notes, we're gonna do this. For both platforms.
know what I started doing? I didn't subtract, but I was gonna do the 35 and then the 25%. But subtract it, because I got the numbers. So we subtract. So. So with that, we pick the one that you pick.
Got it, Dean? Fine. Staying warm? Pretty much.
Professor, do we add the square roots, or do we solve and then square root?
Solve and then square root the whole thing. Wait, no, you add and then square root.
Add.
Square root is
Square
the
root
last
is
thing,
add.
last thing you do.
Does it work if you square root it and then add it? So it's-
I don't think so. Yeah. Yeah, exactly. Multiply by 1.96.
My calculator doesn't have enough zeros for me to.
Yeah, the cell phones are gonna be hard.
You know, use your calculator?
That is the calculator. Can you store,
I need another bag for that.
can you store numbers in that?
Yeah.
Yeah.
It's old school, but it works.
Nice. Nice. Hey, what's your name again? I'm sorry. Devon. Devon. All right, good. Any questions?
No, not right now.
Thanks. Designed by you or?
No, I found it on Amazon, actually. I think it's this one.
We found the whole computer or
No,
or
no,
the
no,
case?
the case, the computer itself is for now, all
All right, are we ready to do this one? All right, so we want a proportion difference in this case, and we are given a sample from proportion 1, sample from proportion 2. We know the sample sizes. We can calculate the standard error. We've got everything we need to solve this problem. So let's see, proportion 1 is 35%, proportion 2 is 22%. The difference between them is 13. So our confidence interval is going to be 13 plus or minus some amount. What is that amount? Well, it depends on how confident we want to be. That's going to give us a z-value. And then we're going to calculate the standard error. For 95% confidence, what is our z-value going to be? Fantastic. All right, we crunch that whole mess. What do we get for the standard error?
0.028252433.
Very good. Store that number in your calculator. Do not round it. So 13% plus or minus 1.96 times that number stored in your calculator. All right. When we take the z-value times the standard error, what do we get?
0.0553746768.
All right, that number still stored in your calculator, approximately 5.5%, 13% plus or minus 5.5. What do we get on the low end?
074625231.
All right, on the upper end?
185374768.
18537.
Yes, sir.
Fantastic. Who can give us the interpretation?
That is right.
Go for it, Amanda.
We are 95% positive that the true population proportions are between 0.07462.
Okay, what did she miss?
Different.
Oh,
Difference.
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 Difference,
All right.
I did.
So we're not very good. Perfect besides that. We're 95% confident that the true population proportion difference between those two numbers. Yeah. Great. Great. Let's just start one more problem, and we'll see how far we get and then maybe take a break, but break is coming up quickly. So let's just see if we can make a little bit of headway on number 42.
Wait, don't erase that. Don't erase it.
Don't erase that, okay. Don't erase that.
Okay, erase it.
Can't see the bottom of the,
No worries. You didn't get to the page. Which page is it?
40.
That's it. says it's 98. Okay. Oh, sure,
Oh, yeah.
So we're 98% confident, what percentage are we gonna be wrong?
2.
2%, no, 2.
Oh, 2 for each side, right?
No, 2 total.
2 total.
How much for each side?
2% for each side. Because there's 98, 1% of each side. Right.
Yes, exactly, so 1% each side. So if there's 1% that's up for tail, what percentage is below it?
Oh, so you gotta subtract 1. Yeah. Could you say if it's below, it's always high or below 1%? To make it 100,
Alright, so 98% confident,
right,
we're gonna get it wrong 2%
1%.
of the time. So there's 1% up here,
right, and 1%.
1% down. We're looking for this Z value
Right,
that separates the upper 1% from the bottom 99%. And what we know about the way the Z table works is it tells us the percentage of area below that Z value. So we're looking in the center of our table for 0.99.
oh, okay, so it is the 2.3, 2.36. All right. 2.36.
6, 3,
3. Oh, 3, sorry. Yeah, it's right here, I circled it, I wasn't for sure. So we asked for sure. I wanted to ask. Because sometimes you get messed up, you know for sure, I would ask. So that you would. Oh, could you go? See what we got here. Yeah,
What's your confidence? Yeah, use the
Are we ready?
Nope.
No? Okay. ready to go? Alright, let's take a look at this one. So in this example, we're trying to compare the percentage of Democrats in print journalism with the percentage of Democrats in broadcast journalism. Maybe someone made the statement such as, there are more Democrats in print journalism. So, I don't know if anyone knows anything about journalists. Print journalists, I think, are the people who make like $25,000 a year and, you know, are writing the truth. Right, so they're more likely to be Democrats. Maybe someone made that assumption, made that statement. And they said, well, journalists who are broadcast journalists, they look good on TV and they are less likely to be Democrats. Does that make, I don't know if that makes sense. These are not my words. Right? Is it just something maybe someone said for whatever reason, there are more Democrats in print journalism than there are in broadcast journalism. So we wanted to verify that. We took some samples. We took a random sample of 1,149 print journalists and 1,003 broadcast journalists, and we found percentage of Democrats in print, 37%, percentage in broadcasting, 32%. So, our point estimate difference, 37% minus 2% is 5%. So our confidence interval is going to be 5% plus or minus some amount. So 5% just right off the bat, right? That's not a really big number, not a really big difference. So I might be skeptical of someone who tells me there's a big difference in Democrats in print journalism versus broadcasting journalism. But let's just wait until we get our confidence interval before we make our final decision. So to get our confidence interval, this 5% plus or minus is going to be plus or minus some number of standard errors. If we want to be 98% confident, what number of standard errors plus or minus are we going to go?
2.33.
Fantastic, everyone good there? And our standard error is this whole mess. What did we get when we crunched that out?
0.20489,539.
0.2.
Yeah. No, 0.02.
Alright. 0.02.
Right.
Alright.
Right.
So, okay.
0, right.
Alright. So about 2%. We all like that?
Okay.
Alright. So it's going to be
So we stop at 8.
0.05 plus or minus 2.33. No, we don't stop at 8. We store this whole thing in your calculator and multiply it by 2.33 times that number that's stored in your calculator, 0.020448. Alright, what do we get for our margin of error when we multiply those two?
0.04774.
Alright, so 4.7%. We're going to take 5% plus or minus 4.7%. What do we get for our lower bound?
0.002259. 59. What we just.
Alright, and our upper bound?
0.09774.
Alright. Who can do the interpretation for us?
I ain't doing that.
Aline did all the fun stuff.
That's the only part I can't, I ain't confident in telling the truth about the proportion of that.
Alright, Ariel, take it for us.
I'm 98% confident that, that's all I got. That the different, hold on.
Help us out, Roxanne.
Thanks.
98%
The
sure
difference
that
between-
the population proportion difference is between 0.002259 and 0.09774.
I know you had it before.
Perfect, excellent,
Perfect.
excellent. Question, Dina?
She's like, perfect.
Excellent, excellent, excellent. So, she is 98% confident, pretty confident, that the true proportion difference is between these two numbers. So it could be as low as this. And what is this? This is 0.2%. That's pretty low, right? That's a very small difference. Could be as high as 9.7%. That maybe we could say is a big difference. But this, no. I am much more skeptical of someone who's going to try to tell me that there's a difference in Democrats in print journalism versus broadcast journalism after looking at this confidence interval. Because, yeah, this is just so close to zero. And zero would mean there's no difference. If this crossed zero, if this could be a negative number, what would that mean?
That it is no difference.
Not just that there could be no difference, that in fact,
They're the same?
no. That there's more Democrats in broadcasting.
Oh.
Yeah, if this were a negative number, that would mean there could be more Democrats in broadcasting. So your whole theory about print journalists being starving Democrats could be completely wrong. There's more Democrats in broadcasting. All right, great work. What time will we at?
We have that again? I
8.
am truly confident that 95%.
So let's come back at 8:21. Jump in.
A lot of places make mistakes. That's why I keep doing it, keep making little stupid errors.
You gotta keep about 10 steps.
Let's go. Here, give me something.
Oh my God. You have that.
Your confidence level is gonna go down.
Yes.
We should go break it, this is the last day.
Population.
Start smoking to that, says the last day. Sorry, it took so long, how you doing? I got stuck on the quiz there.
Yeah.
Yeah. It got confusing. It was simpler, but it was confusing. You know what else is my problem now? I have to remember what was complicated. To put the whole number?
Yeah.
Was I'm gonna be off by cents.
Yeah. No, I get it.
Yeah, I got it right. How about you, man?
All the same, sir.
Canceled at the
Oh, okay.
Oh, okay, so then you can miss out.
And you can use it credit.
They charge you like
Water is
that.
the best.
I like to use that credit card.
What is the best?
Maybe
I don't know.
What's up, man? Welcome to the Bronx. Birds of Manhattan.
He usually be in Josh area, I'm surprised he is.
Yeah, everything's cool, man, right? You can drive, you can take the train until something happens.
You can't drive to Manhattan.
Now we're driving.
Hold on. When you hit the West Side Highway, which I used to do it often, you go fast. There's
Yeah,
no
that's
traffic.
fine.
Yeah, then you
Yeah, I know
have
how to get off.
Driving
And then you hit the dots, right? You hit the piers.
No. Yeah. Well, something happens, something crazy to the train, then you get home like 10 days later. Your 45 commute is like 3 hours.
Yeah, that's
I
why I stopped
know.
looking.
Some flare fell off the tree, you know, caused a little accident.
It would take me from here.
Bottle tumbling down.
Over an hour.
My last job says, do I want to go to the city? I was like, no, back. And I was like,
Wait, where were you based before?
I was in,
Yeah.
Like, well, how far downtown?
Wall Street.
Hey, lady.
Oh my
I
goodness,
was all
God,
the way down.
God protect you down there, you know?
Yeah.
Listen, just the little streets down there, it's annoying to
Well,
bump into
that's
people.
why
You have to walk on the streets.
I didn't drive. I was trained down. taking
No,
over
driving
an
would be
hour.
like 2 hours getting out of there.
I was like
I used to drive
that.
daily.
3 days ago, I went to a meeting at Fort World Trade. It took me about an hour and a half.
I used to drive daily downtown Manhattan, 29th Street and Park Avenue. And traffic was so bad sometimes, around 3 in the afternoon.
Oh, yeah.
Hold on a minute, that it would direct me through New Jersey. Take the tunnel, right?
To get
And
out.
come back on the George Washington
Probably,
Get
would
out.
make sense, yes.
to go to Riverdale. Yeah,
Probably would make sense.
I like your uniform, it's kind of cute.
I gotta go to work after this.
I do it.
It will be put up.
Right?
I would drive on the
Retire.
weekend.
I can drive.
Weekdays, it takes you so long to go from west to
That's
east.
not too bad.
What's
Okay,
that?
so you're gonna drive it?
Going from
Yeah,
west
I
to east takes so long, it's ridiculous.
Oh, no, you cannot. Let me tell you what the quickest way from east to west. Hit north as much as you can and then cross. Not to the last very last one, but that's what I used to do. I used to be a car shirt. Yeah, that's what I used to do.
I don't know.
Yeah, but
Lower East Side is much.
if you're downtown, you don't wanna go up north, you go.
Listen, sometimes some marathon stuff, man.
Well, marathon or
Is it a bicycle?
parade or.
Santa Claus.
No, that's on Hoboken.
They closed it.
I think they banned it already.
Yeah, they have.
You know, I hate, when I was driving, I hated everybody because it was everybody's parade. I was
And they probably hate
It was
you.
Dominican, Puerto Rican parade, Arab, Jewish.
gave me if it kills me.
And I was like, Jewish people have parades? And when they see all the kind of people, is it Mexican people have parades? You know what's funny? You know what else? When you see the parade, just look at the calendar. What's today's day? Like you're gonna remember a year from now.
Missed it already.
Did you get all the notes, man?
Yeah. Yep, I make sure I go back and I can do it myself, because I
Going to the
Yeah, but honestly, for a city this big, for a city this small, with a population this big, traffic not that bad.
Well, yeah, I guess. Never been
Go to others.
I got one.
Well, yeah, I know what you're saying. The R is crazy, and there's not that many people. It's a mule, a horse, and a chicken on the
Canada's basis though.
Mexico City's worse?
I'm going to death.
Yeah, it's so small.
I kill somebody. You
Try
know,
going in the winter.
he says Mexico City is worse. I was like, Mexico City, I kill somebody.
In February, usually they have a winter fest. It's the best time. My ex-girlfriend lives. But we go skiing up there, and in February they have a winter fest where they do food and wine and music festival, and they usually set up toboggan on the street, and it's free. And
Sounds like you're going back.
I don't know.
To her.
No.
I'm just kidding. I already got food. I'm waiting for somebody to arrange or something. I'm just kidding, man. I like driving.
Whatever set sail already, set sail. Move on, you don't call them.
Do you like road trips?
Oh yeah, I'm a driver. I got to one point where I put 40,000 miles on my car.
Walk out. Where the hell you
Although
go?
now
Oh, everywhere.
China?
I go everywhere.
Jesus Christ. I don't know how many miles the United States has.
You
You did that in a year?
Like, you know, the
Hold on, you didn't do that in a year, did you? You didn't do that in a year. In a year, 45,000? Wow. That's what I did, that's what I do when I taxi drive.
Well, then again, you know, well,
45,000
work
miles.
commute adds to it. Like, you know, if you go
Hey,
to work
man,
at 25 miles, that adds on to it.
What's up? Do you get to do it or?
I drive from Maine. Well, the only time I would not drive
I
is
send you the
past
Excel.
8 hours or 9
That's
hours.
all. I
That's
didn't send
just a
it.
waste of
Yeah,
time.
the quiz I did because I was late.
Yeah, that's the
That's my gap. I made
Oh, you gonna do
it.
your leave?
That's the limit.
Huh?
I
You mean
probably
do
never use it.
I did the quiz for today.
Like right to the.
Everything that was due today, I did. I didn't redo it. Yeah, I was just doing a lot of stuff. Huh?
Did you send
What
it?
do you
Yeah.
wanna do with that?
It was
send
1
both?
point before GPS.
I sent you an email.
And we had maps
I gotta
that
check.
don't.
Yeah, this is for the Excel. You see the first one on the Excel? I put 85. I guessed that one. So I didn't know how to do it in Excel.
Right.
And then
Yeah,
we
I just
stopped at the
guessed
rest
it.
area, we're like, oh, let's wait for
Check my
them.
email
We
right
were
now.
on walkie-talkie, couldn't get reception. Oh, we'll sit here, we'll probably see them drive by, we'll catch up. Nowhere, of course, they went on 17, and we were sitting there without a map, without the destination, we're like,
You know, this is something that I concentrate.
and then luckily,
Where
before
you-
we
where
were
you
at
sleep?
the
Where you go to?
hotel, tent, campground.
I like
You know, when you're
I
young
love
and
camping.
you're, you know, the world is your oyster, you can go anywhere and sleep anywhere, you don't have no kids. You don't need a bathroom.
I know.
I don't know if I wanna do that, cause I
I
don't
don't have
Yeah, that was
kids.
crazy back then.
You know, when kids get there, their relationship you have is not the same.
No.
It's new,
And I gotta-
you get to meet your wife.
That's what you.
You get to meet your husband.
Now, let me tell you something, that's
And
something
see if
that
we
you
can hold
put
this
into
together,
it.
that's what.
I've read it, I know a couple where they say, you know, right, we have kids,
don't know what you
they tell their kids, after 9 o'clock, you all need to be in bedtime, mommy and daddy time, we can sit there and watch TV, we talk,
Yeah.
you guys need to go and,
Yeah, 9 o'clock.
it's our time.
In the R, it was this, Colgate, announcement on TV, that it was like by 8:50 or 8:55.
I chose
By 9 o'clock,
marketing
we
because
have
Just doesn't mean that, you know, once you have kids, your life can.
marketing like some sort of
I'm not a social person, so my
but I
life
wanted to
revolves
know
around
how
my
to be
wife
more,
and my kids.
to.
So we go
like to
everywhere
know the
together.
consumer
Yeah.
side,
Not a
what
place-
drives
I drop a lot of friends from
Yeah,
consumers
there's
and
not a place that I
how to
don't
do
go
a
without my
marketing
kids.
plan
I have a
and a
question.
campaign
What do you
and
do
all
for
that,
fun?
so.
Just go all the time and stuff?
Yeah, we go biking, we go skiing, we go rollerblading.
Yeah.
Um,
For sure,
the
but
closest one is
again,
in
you know, you gotta,
Connecticut, the border of
it
Connecticut.
doesn't touch
and,
everything, so it's like, you know, I keep the book so I
I
can
just
go
showed that
back.
video of my 4-year-old.
Because now my
doing that by
background is
himself.
And
That's so cool,
I
man.
have two
When you
organizations
teach
that
them,
we
and then, you know,
started.
at
One
that
is
point.
You know what, I got
the
my daughter into
marketing,
swimming
and that's
lessons.
what I really wanna be able to market.
That's
And
I'm tired of boys.
that
Swimming is
business.
good, you know, is a.
But
But
best
this year,
investment ever.
next
She's
year,
gonna
I'm
be 3.
gonna
You think
be
she's-
working at a tax
yeah.
office
My
again,
daughter
but he's
swims
gonna allow me to now do the
Yeah.
marketing
Okay.
for all of his
Take her with me
offices.
for the first year, and after that,
Yeah,
let
so
them-
it's like,
let them take over.
you know, this is where I can really,
It builds their
really like,
confidence in the water, and then, you know,
test out
even when you go on
everything, yeah.
vacation, you're in the
you
pool,
know,
you're,
see,
at
but the
least
only
you're not
down thing about that
Crazy about
is,
not
you
so
know,
worrying,
people,
like, you know, that.
first of
Yeah.
all, people don't
Offended.
wanna change.
Yeah, that's what I'm gonna do
And
for a
then,
birthday.
When you say that, do you mean
You know,
the owner, the
Ever
owner,
heard of Stuart?
yeah,
The
so
guy
that's
that
one
owns
thing.
the
The
farm
other
shop
thing that
in
I'm
Yonkers.
noticing
Yeah.
is
No.
his,
So his son died
customer base, like he pretty
in
much
their pool
knows who his
because they
customers
turn
are.
around
So there's
for a
certain
couple
things that
seconds
like
and
I would
get
say,
drowned.
let's do X, Y,
And ever
and
since then, he
Z.
started a
And
foundation where, you know,
based on his
bring
customers,
alertness and
it
how
wouldn't work for
children
them.
swim.
You know, perfect example,
It only
you
takes
know,
a
when I,
second. You got
there's
the kid,
one
you got
office
the
that
kid,
I
no?
actually managed, and we used
At
to
least
do
if
the
they
big
know how to
check,
swim,
you
then,
know,
you know,
you
they're-
come
your
in, when
head
you get
is
the,
in.
your, incentive for coming in like $50, right?
Oh, okay.
You would take a
The
picture
first
with
thing
the
that, you know,
check,
like if the
and,
children,
you know,
they
we
teach
could use
them,
it on
you know,
social
the
media.
safety is like,
His
take to the
offices,
front, you know,
they
to
used
the
to
surface
do
and turn
that,
around.
but they would put people's picture in the offices. So now you have friends and coworkers saying, they got money, they owe me money, and it turned into a problem. You know, cause it's like you're, you know, they're,
Now, cause you're publishing, this person was here, and
for
then
sure.
people go there and you don't know the other person. That's not his problem, no, that's the people's problem,
But
it
it's a
turned
problem. It was a problem, so he's like, no, we can't do that. So I'm like, okay, you know, but again, so now I have to
Now you have to
see
figure
for
that
that
out.
community, what works for them and what's gonna get them in or what's gonna bring them back. So then I was thinking, let's do like during the town season, go out to them, you know? He's like, that ain't gonna work because we tried in the beginning,
Yeah,
people.
but just cause you try to begin, it doesn't really go again.
In that case, I'ma just say no, because again, I'm dealing with, he already knows his community, he knows who his demographics are, you know, so I'm not gonna force that.
Does he know, like, what's the percentage of the new person that he He gets it every year.
And now that's where I'm gonna have to like look at those numbers, because for him, it's more so where they just go based on the volume. They're not really looking at was this new, or they go based on how much each office needed.
It's pretty much. Yeah, but they help. But you wanna see like how many more new customers you got.
Exactly.
Because if you have a low number of new customers that you're getting, they wanna make that number higher, so that's where the more, you use more people.
Right, but they never looked at it that way, as far as never doing a real marketing plan, or, their marketing is being, that's what they're thinking, they have the waivers out there and they think, but I don't even think they're gonna be doing the waivers anymore. Because again, that's not, everybody knows you're there, that's not bringing them in.
No, I left 5 o'clock. I left.
Want me to email you the Excel file?
You have to know.
So I wanted to just go over.
They gotta come in anyway,
I'll
we're
try.
gonna bring them to you.
I'm looking at it, I'm like, I don't remember how you figured it out.
I can say how to do it. Sure. Because I'm sure it's another thing, I figured you have to take away a hundred, they want their concessions from lunch, because HR brought, they don't have to set incentives, but they lock their comments there, and they have what's called an
You were looking at exercise 6, right?
So they'll give you money.
So if you do that, you take the and then you.
Yeah, but it's a credit card that you can get this month, but you're gonna have to come in and do your taxes in the new year. So that's how they lock people in.
This is 90, this is 99, 80.
And it's saying like you can't go anywhere else, because then you're gonna owe them money.
This one will be, .01 and this is .20.
So,
That's what you
Yeah,
have
this
to
was
do.
more easy.
That was just had to take away from here from the public franchise. Oh,
Because you just use the same exact
cause I was
formula.
gonna say maybe like the difference.
That's what I did. I
The other
just
ones, you
copy
gotta do
paste
some
down.
funky
I
stuff
don't
like
know.
I actually copy paste down
He
to
might
all
have
of
the
them, and then I
same-
just changed as I went through
Yeah.
here. The other thing, this one, that other one with the 2, I was like, you see, you go to the 2, you did it different, separate, right? And he told me to, he told me to do it separate. But when I was doing it, I was like, looking, I was like, okay, do I do 2 separate, minus it out? Or do I do the 2 180 and then 144 together and then do the whole thing? That's what I did.
Cause I mean, if you do,
Before.
I mean, I always
If
say,
I give out 2 of them, what did I do?
rapid refund makes no sense, because you're paying extra money, which HR normally pays them, so that's why they have that incentive, right? But at the end of the day, you get it.
But you know what it is? It's the new ones that offer more, like $100 as opposed to eliminating. You're just gonna give them 50. That's what takes away from because again, for those for the first ones, people are just thinking about they want money, they want money. And they lose a lot of money because they're not willing to go up. Yeah, because there's like 1/3 Avenue on 49th Street, you have like 3, and they're all competing, so I'll give you 100, I'll give you 110. So, you understand? So they're going, clients are going away for that
They're
reason.
going away for that reason.
Minus
Or he just retains the same clientele, and he's not gaining any.
Alright, so let's go ahead and get started. Actually, let me double check.
They're not willing to give them more.
Still going.
And that's what I'm thinking. I'm trying to see where, I guess we're in the formula.
Alright, so in this last section of the material, we will study the difference between 2 population means. So, the example I gave at the beginning of class, we've got town 1, income is a certain level, town 2, income is a certain level. What's the difference? Alright, we have a point estimate for the difference, but that's just based on a sample. We need a way to quantify that whole thing. Now I should mention, we've already got some skills we could use to solve a question like that. Suppose we get a estimated income in town 1 as 71,000, estimated income in town 2 as 50,000. So difference of 21, and we could do a confidence interval for town 1 and a confidence interval for town 2. Like we could already do that. You already know how to do that. But the question is, do we take the upper bound of both, lower bound of both, the center of both? What if they have different standard deviations? In any case, we'll learn the formula just to combine the 2. we'll use something called the sampling distribution of the sample mean difference. What do you think there? Uh-huh. Predictable sampling distribution qualities, which will allow us to build the confidence interval. All right, this slide should look exciting to you. So take a look at the title of that slide.
Professor, are you gonna say anything else other than the sampling distribution of sampling something?
That's all. That's all I say. If I had $1 for every time I said that, I'd retire. So every time I say that, someone needs to give me $1. We get a deal like that.
Millionaire.
You can just take turns. It'll only be $2 or $3 a class for each person, right?
Monopoly money?
All right. So let's read the title. Let's tell me what that means. Let's tell me what the center of that distribution is, and then let's tell me what this thing means. I'll start us off. All right, this x bar 1 minus x bar 2. So that's sample mean in town 1, sample mean in town 2, the difference between them. 1 minus 2. So this frequency distribution consists of a bunch of these. Thousands, millions, in fact, all of them. All of the possible mean differences. What is this frequency distribution called?
Sampling distribution of the sampling mean difference.
Fantastic. What is the sampling distribution of the sample mean difference?
That's those things right there. Then you got the hour, the mean the difference is there,
Yeah?
that sample there, whatever you wanna call that sample. Right?
Okay.
And then you have the difference between the two of them.
Okay. You're saying a lot of the right things, but just give me a definition. What is this thing?
The standard deviation.
Wait, one second.
Okay,
But just give me a thumbnal definition.
Frequency distribution of all the sample mean differences.
Fantastic. This is a frequency distribution of all the sample mean differences.
Frequency, okay.
What is the center? What is the mean of this frequency distribution?
The right answer.
Right answer.
Right answer. That's saying the right answer.
Everything can be
You
that.
can't get that wrong.
The right answer, also known as the true mean difference. If we had all the information in town 1, all the information in town 2, what's the difference between them? That is the most common, the mean, median, and mode, and that is the center of this normally distributed bell curve. Now, there is some deviation. Sometimes you're going to be a little high, sometimes you're going to be a little low. Speaking of deviation, tell me what this is. Just read that to me, I'll explain this part.
Standard deviation of the sampling distribution of the sample mean difference.
Fantastic. This is the standard deviation of the sampling distribution of the sample mean difference, also known as standard error. It has all the components we would expect. We need to know the standard deviation of the underlying population 1 and the standard deviation of the underlying population 2. The bigger those are, the bigger the standard error is going to be, because they're in the numerator. We also need to know the sample size. We take a big sample from town 1, that's going to decrease the standard error, because we're going to have more precise information. Bigger sample from town 2, we're also going to have better information. This being in the denominator is going to decrease the standard error. So everything is in a place we would expect it to be, and the statisticians have told us that if you put it in this order and do the square root, that is going to give you the proper calculation. So we'll do that calculation, and we'll say how confident we are based on our confidence interval. So the sampling distribution, the sample mean difference, probability distribution of all the possible values of mean, sample mean difference. The fine print under here just reminds us that mu1 minus mu2 is the true mean difference. X bar 1 minus x bar 2 is the sample mean difference. this frequency distribution will be normal as long as we have large enough sample size. Sample size is 30 or more from both populations. The center is the true mean difference. It has a standard deviation that we have discussed. Confidence interval. So our point estimate for the confidence interval is our sample difference. So in our sample, town 1, 71,000, town 2, 50,000. 21,000 is going to be our point estimate for the difference, plus or minus some number of standard errors. How many standard errors depends on how confident we want to be. So we'll find a z-value based on our desired level of confidence. We'll crunch the numbers for this, the standard error. Okay, now there are two, this is in theory what we would love to use, but there are two little things I want to note. Remember, if we do not know the true population mean, then we will not know the true population standard deviation. Remember we went through that whole thing? We used this as a crutch initially and said, let's just assume we know this, but in reality we don't know this. So we made two adjustments. If the population standard deviation is unknown, we make two adjustments. One, instead of using the population standard deviation, which we don't know, we use the sample standard deviation. We calculate that ourselves if we have to, or it will just be given to us in questions that we will do in this class for the most part. The second adjustment is instead of using the Z table, we switched to the T table. Okay, that's what we've done in the past. Now in this particular case, statisticians are okay with just using the Z. Because you're using two samples, you have a larger sample, if they're both over 30, you have a larger sample size, and they figure that the two samples have more moving parts which will cancel each other out and cancel out potential errors. So as long as samples from both are over 30, you're good to use the Z distribution. Now if you would like to use the T distribution just to be conservative, that is fine. So you have the option, you can either use the T distribution or the Z distribution. Okay. Let's do a problem. Let's take a look at page 290, number 32.